equations today, Laplace theorem today. Okay. So this is the huge question. I clubbed most of the questions I could get and combined it in a single question. So integration 0 to infinity e raised to minus 2t whole bracket 4 e raised to minus root 2u integration 0 to t d by du of sine h of u by u plus e raised to u minus 3 plus 4u cube whole bracket du of whole bracket dt at t is greater than 3 or 0 otherwise, then we have to find L of f of 9t. So what we have to do here is when L of f of 8 is there, okay, so this is actually second shifting property. So what happens is here, not second shifting, I guess it is change of scale of property. So what we do here is we do 1 by a phi of uh, s by a, right? And by the way, I'm just doing this right now directly. Then obviously if there are some wrong formulas, I would try to verify it. Okay, so yeah, this might be wrong, I am saying that only. Okay, so sorry for that if it is wrong. So this is this one, and then we have to go for uh, yeah, so we have to go for a first shifting property. Okay, so let's say L of e raised to minus 80, okay, e raised to minus 80 f of t is equal to phi of s plus a. Okay, so what is phi is the result of previous one. Okay, so you have to also understand the property of this Laplace, okay, which is 0 to infinity e raised to minus st uh, e raised to minus st f of t dt. Okay, this is the here this is equal to L of f of t. Okay, f of t. So now what do you have to do? Yo, once the one folks came up, what's up? Welcome to the stream. Thanks for coming. Really appreciate your visit. Thank you for coming, bro. Wow, come up in the chats, bro. Yo, 11 folks. That's crazy. That's crazy. Welcome to the stream. Thanks for joining. Really appreciate it, bro. For real. Come on in the chats, bro. Let's go. Wow, come on in the chats. We can, yap something. So yeah. What I was doing is now I decoded this stuff. Okay. Yo, 13 folks. That's crazy, bro. Like that is dope. Yo, man, welcome to the stream for real. So what I have to do now is I will show you linear proper. Yo, Shrabarni Chattopadhyay says, "Yo, hello, Shrabarni Chattopadhyay." So she says, "What are you doing?" I'm actually doing, undergrad level mathematics, which is Laplace theorem. So I'm trying to solve this Laplace equation. Are you a physicist or mathematician? Shrabarni Chattopadhyay says. Nah, I'm nothing. I'm just a full time YouTuber with a dumb brain to think he can do maths. So yeah, that's who I am. I'm a simple nobody. So yeah, what we are trying to do is here I would take K1. I hope you got the answer, Shrapani. So yeah, so L of K1, so f of 1t plus K2 of f of 2t. You there, Shrapani? So L of k was, so let's say k is a constant. Okay, these two are different constants, k1 and k2, and f1 of t is a different function, f2 of t is a different function. So what you have to do is if we do this, so we can just if there is addition or subtraction, we can just separately do this Laplace and it would still say the same. Shabani says yeah, oh yeah, so you are there. I hope you got the answer right. So k is a constant, so we can take the by the way, we can take the constant out and we can take the Laplace of the function, then we can directly multiply the constant. So this is how it works. K1 Laplace f of 1t plus k2 Laplace f of 2t. I'm just revising formulas right now overall, then I would start solving the question, okay? So, because formula is the base that we need. Even if you write the formula, then at least people would know that you know the stuff. Maybe you don't know how to apply it, but at least formula is the basics, okay? In maths, formula is the basics. That's how it works after, undergrad, right? Maybe solving works before that, but formula is always necessary in maths because it's like a puzzle, and you don't know the if you don't know the strategy to solve a puzzle, then you are cooked. That's how it works. So I showed you this. Okay, let's just show you some basic Laplaces. Like let's say, yo, 16 folks. Kevin Mori 3955 says, "What do you apply this equation to?" Okay, so Kevin Mori, Kevin. So I hope I can call you by your first name, right, Kevin? So uh, may I? So Kevin Mori. So this equation is. Thanks, bro. Thanks for the permission. So, Kevin, this is your equation. So, this equation is actually a function of Laplace theorem. So, I'm trying to solve Laplace equation. So, there are different rules in Laplace equation. So, I'm actually laying out the rules that we are going to use later in the question, in the Laplace equation question. So, this is actually linearity property. Like, if you take Laplace of whole of constant into first function plus minus constant into second function, like two functions added and there are coefficients, then how to solve them? Okay, I'm laying the equation for that. And also there are like this is integration 0 to infinity e raised to minus st. I told you here, right? Okay, that I have not written. Let me show you first things. Yeah, I have written it here. Sorry. So integration 0 to f infinity e raised to minus st f of t dt. This form, if you see a question, this is definitely Laplace equation. So basically, what normal people would do, like till undergrad, if you have studied, then you would simply try to integrate it, and this is kind of like troublesome situation. So if you know Laplace, then you can just do it more simply because you know the patterns. Maths is about knowing the patterns and shortening them so that you solve it efficiently and smoothly and faster. So that's why we are just finding a pattern in integration and making it short. That's how what we are doing in Laplace equation. Like gamma functions also do the same stuff. So it is just like that. So let's say you have a is a constant, okay? L of e raised to minus at, then is it is equal to 1 by s plus a, okay? This is the equation. So I'm giving you now standard Laplace. Kevin Mori C3955 says, so skip integration. Kind of, yeah, hack like stuff, but only if it is in this form. Like, let me show you. Like, gamma function means 0 to infinity. What do we say? Yeah, e raised to minus x into x raised to n equal to n factorial. So what do we do here is, this is gamma function actually, okay? This is gamma function, gamma of n. So if only in this form your equation exists, then only you can skip the integration and just write this, or the power only that factorial. But if it is not in that like that scenario, like it is not in that form, then you can't skip the integration technically. But yeah, these type of integrations are tougher, so you get the cheat code to you know do the skip the integration. That's how it works, right? So yeah, you get cheat code when things go tough. So that's how things go. Like in this is gamma function. There are also series like to skip integration. Yeah, got Kevin Mori says got it. Yeah, that's good. Thanks, bro. Thanks for understanding. So yeah, that's how it is. Like this is just like a cheat code. So e raised to minus 80. Now I would talk about let's say cos 80. Cos cos 80. Then what would happen is, well, also then I should also talk about sine 80 because sine and cos are related, like kind of opposite brothers. Like they just fight with each other. Like I'm the opposite. So if it is about cos 80, then Okay. So if it is sine 80, we get the opposite one. Like this is s here. So you would take a here, okay? This would be s square plus a square. Okay. Now, if you have cos 80, by the way, I want to repeat it again that I may be wrong with these formulas. Now I am doing it from my mind, which I have. Later on, I would check once with the notes, and I would correct it. Okay, so re-verify it. So kindly just vaguely keep it in mind. Okay, after the I give you verified formulas, then only do that. Okay, so I'm just trying to give you the techniques. Like, see, this formula you don't have to remember it. Just you got a constant, you got a function. Then take out the function, take out the constant, take Laplace of function and multiply it. I'm just trying to give you the like memorizing like tricks and all, I guess. So if you have two functions, f1 f2, then you don't need to take Laplace of whole at once. You just can take separately and add them. It is the same thing. Okay, and this is the format: integration 0 to infinity e raised to minus st f of t dt is L of f of t, and e raised to at is outside of the function, and you have to take Laplace. Then in the result you just have to add s plus a, okay, in place of s. It is mostly, let's say, uh, for all of these L of f of t, you get the result phi of s, okay. So yeah, so what you do is in f of t, f of at, let's say, so you have like here I have given you L of f of 90. So we technically take L of f of t, which is phi of s, but here I have a constant with it inside of the function. I just can't separate it. So what I would do is I would take 1 by a, that constant I would just divide it here outside. Then I would divide it in the wherever s is there in the function in the result, okay. So that's what I would do. Now let's say this is so e is the most simplest function here. Like in most integration and derivation, e is the simplest function, but yeah, in this too. So what I have to do is 1 by s plus a, and if this is plus, then you have to do, let's say this is your e raised to at, then what you have to do is 1 by s minus a. Simple stuff. So in L of cos 80, then what you have to do is, so since cos doesn't have s at starting, sine has s at starting. There are only two variables in this Laplace, s and a. T is the first variable. You have to convert it into s and a. Okay. So here are s and a. So s square plus a square will be every time in like trigonometric functions. But when it is sine 80, since sine has this is memorizing technique. Okay, I'm not saying this is the real stuff, but since sine has s at start, you take the opposite of s. Like s, there is, the other thing is a, so you take a on the above side. Since in cos there is not s is not at the start, then we take the opposite. We take the s at the start, s by s square plus a square. Okay. Now, so this is one because as like remember it like this. Okay, I'm not saying that it is the right thing. So 1 by s plus a. So since there is s square plus a square, imagine like I have multiplied s to numerator and denominator to balance, right? So here it is instead of 1 it is s, here it is s square plus a square. Like remember like that, okay? Because this has a huge derivation, and if we try to do that, obviously that's gonna take a huge long time, it would take centuries. So now L of cos, L of sine, now we are about L of sine ht, sine h of 80, sorry, sine h of 80, then it would be, by the way, same stuff, okay, cos h of 80. Then what would be there is s sorry, this is sine, so opposite, a by as same stuff, but here it would be minus, okay, since it is hyperbolic, and hyperbolic, as you know, converts to imaginary numbers. And what is imaginary? Root minus 1, and this is in square. So let's say root minus 1 square is minus 1. So that's how you have to remember it. If you have studied hyperbolic function, and if you have not, you can check it in my threads channel. Like you have Instagram, so there is below there is some thread stuff, so you can check that. Like my thread ID is at the red big brother 4644, so you can check it out on that. So on that, I have given notes of hyperbolic functions. You can remember that. And you would mostly see that hyperbolic converts from imaginary numbers. And imaginary is like for multiples of root minus 1. And root minus 1 square is minus 1 because we are taking in this, we take s square and a square like that stuff, right? So we take it in square form. So h, so I took like I, it would be multiples of I, so I take minus like I square is minus 1, so s square minus a square. Here cos, I told you in cos, c is there, s is not there, so s is the opposite stuff. Let's take s. We are just teasing this function, bro. You don't have s, I would show you s here, ha 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 ha. So like that's how they do that, okay? Like they don't do that intentionally, but yeah, that's how the function looks like. Yo, 9 people in the stream, bro. Welcome to the stream, bro. What's up? Thanks for joining, bro. Welcome to the stream. Really appreciate it. Yo, why don't come up in the chats, bro? Why don't come up with the chats? We can, yeah, bro. Like we can just yap anything, right? You can just say anything, like ask anything or say anything. Yo, 13 people, bro. Really appreciate it. Thank you very much for the support. So yeah, we have done hyperbolic, trigonometric, and exponential. Now I have to also give you L of, let's say, k is equal to k by s. Let's say k is any constant, so it is k by s. Simple. Now what you are gonna do is, okay, L of t raised to n, okay, t raised to n, it would be, it is actually gamma function, but I would simplify it and give n factorial. This is actually gamma n by s raised to n plus 1. But since I just now told you before when Kevin was asking something about this, yeah, Laplace, like how to what its application is. I told you about a gamma function and I told the formula that gamma n is actually n factorial. So I just simplified that this gamma n to n factorial as raised to n plus 1. That was already here. That's how it works. So I guess standard functions I have done. Now what I would do is, so I have done definition of Laplace function. Okay, done. Now, okay, multiplication by u, multiplication by t, that is actually called. But I have taken u to make the functions much tougher, so that it looks much tougher, so that you fare well when you have tougher questions, so you can fight back better. So yeah. So did I do first shifting property? Yeah, I did that. Did I do second shifting property? Okay, okay. I'll do that later, I guess. Let's multiply by t, okay? So when you multiply this t to f of t, then what happens is equal to. So let me tell you one thing. Like when you are multiplying t, you would apply derivative, okay? You would apply derivative. When you are dividing t, you would apply integration, because let's remember it like this, because derivative reduces power. Opposite, this increases addition, right? Increases because of addition. Like everything is going opposite in Laplace theorem, okay? So multiplication increases because it is repeated addition, addition repetition, and it reduces power, which is actually repeated multiplication. So they are kind of opposite, I guess. So that's why these formulas apply like this. So whenever it is multiplication of t, then you have to take d by dt, d by ds actually, but whatever. But this you can remember this much better, I guess. And when it is derivative by t, just go back to multiplication. That's how it works. Simple. Okay, I have to erase this so that I have much space. And when I have divide by t, then you have to just go for integration by t, right? Let's say not bring double integration now. I would bring that later on to confuse you later better. Now I would take that out. So yeah, when it is division by t, you can just go to integration, which is opposite. Like I told you, this increases power, by the way. Increases power of function, if you know the pattern. Power of function. and this is repeated subtraction, which reduces the number. Okay, so these are opposites. So when you do division by t, you apply an integration formula. Then when you do integration, you do division by t. Simple stuff, right? So from this chart which I showed you, what do you think? What would be multiplied by t formula? Definitely it would be derivative. Okay, so what I would do is wait a second. Okay, okay, so what it would be is s raised to n. Let's say this is t raised to n. Why not take general formula? So t of any power is getting multiplied, so it would be s sorry, wait a second. Okay, wait a second. Minus 1 raised to n d by ds raised to n of f of t. Okay, oh sorry, not phi of s, sorry, I really forgot about that. So yeah, this is, since you have phi of s, you won't do phi of t, right? Definitely you won't take derivative of t, you take derivative of s. So whatever the t raised to thing is, like n, that times you have to raise minus 1 multiplied to d by ds, and just take that much times derivative, that much raised to n. Let's see, this n means times derivative. Okay, you take times of derivative, you take. Okay, so what did I tell you? Multiplication goes to derivative, derivative goes to multiplication. Simple stuff. uh Now what I would do is, did I tell you about for first shifting property? Yeah, I told you there is change of scale to yeah, I told you change of scale, change of first shifting property, second shifting property is left. Okay, let me do that. L of, let's say, f of t minus a is equal to e raised to minus as phi of s. Simple. Let's say this is a function. Okay, I have to first explain you this. So f of t is wait a second, f of okay, wait a second. Okay, let me tell you another thing. Let's say g of, so this is actually function inside function, that's why this is so complex for me to explain. Okay, function, this is function in function. Like t minus a is a separate function, right? This is not t, like one variable. You are taking Laplace of two variables in a, in a linkage, in a bond, like in a kind of equation, like relationship, like t and a are in relationship. So you are taking two variables relationships. Laplace, I know a is a constant, but still it is a variable. We don't know till now what is a. Okay, we just know that some number will fit here. Okay, so we have to generalize it, right? So let's see, uh, let's say a variable is, let's say a function is b is f of t. Sorry, let's take g of t. Okay, g of t is g of t sounds better. Let's say g of t is t minus a. This is a function. Obviously, this is a function because this is not a single variable. This is a rule of a variable. Okay, that you do t minus a sometimes, whatever number you get. Rule of variables. Okay, and that is what function means, right? You just put numbers in it, input numbers in a rule, and it change function, right? That's how it works. So g of t. Yo, 2 people came to stream. 3 people, bro. That's crazy. Thank you for coming. Welcome to stream, man. And whoever one person was there till now, I really respect you, bro. Thank you for staying, bro. Really appreciate it. So g of t is t minus a. So this is one function. So what we are doing here is we are taking f of g of t. We are not just simply taking a function of a t variable. We are taking function of a function. We are taking function of a function of a variable. We are taking function of this function g of t. G of t is itself a function of t minus a. So this is like inception of variables. Like, this is beyond Christopher Nolan. Okay, this is beyond Christopher Nolan's movies. Okay, this is crazy. This is going into Inception, right? This is going into Inception, bro. This is crazy. Okay, so that's why this is much more tougher. That's why we have to take the result and we have to multiply e raised to minus s. That's why we have to take extra efforts. Okay, so now I would erase it. Okay, so let's say g of t is this. So now this is how I can indicate this. Now what did I tell you? I have completed multiplication. Wait a second, let me check with the question. I actually covered most of the things in the question, so I'm checking. That's why I'm checking the question. U cube, right? Okay, that also I've covered here. Yo, Kevin Mori is still here, bro. Whoa, what's up? He's still here. Thanks, bro. Thanks for being here. Really appreciate it, bro. Yeah, I was thinking like, where are you? So you are still here. Really appreciate it. Thank you very much. Really respect, bro. Like, you could endure my yapping. I really appreciate that. I really respect that. Thank you very much for being so kind to be still staying here. Really appreciate it. So 12 people in the stream, that's crazy. That's great. Okay, that's great. So since I have covered, so I'm just laying out the rules. Like, I'm just laying the, like, what do you say, like, laying the holy scriptures for a ritual. Okay, these are the holy scriptures you have to apply for this ritual. Okay, so that's what I'm doing. So I'm just checking that have I covered everything. So I have covered the definition. I have covered the multiplication by t. Yeah, I have covered that. Multiplication by u e. Yeah, for shifting property done. This is integration. Oh yeah, I just forgot. So L of integration of 0 to infinity, I guess. 0 to t. Sorry, we are talking about t. 0 to infinity is covered in integration, like Laplace stuff. Okay, 0 to integration 0 to t. uh, let's say Laplace of f of t, and this is actually I'm talking about outside, outside the function of t you have already solved. After this you solve the outside things. Okay, like outside some integration comes, outside some t multiplication comes, extra stuff. Okay, only t stuff are welcome here. Okay, we can't solve any other stuff, only t stuff we can solve. Okay, so Laplace of integration 0 to t f of t. uh Bro, like, Kevin's concentration is really dope, bro. Like, it's inspirational. Like, he can focus on a maths lecture for, like, math session for a very long time. I guess he is a kind of a mathematician. I guess he's a good mathematician, I guess. So, and that too from a noob like me, he can endure this session, then he's definitely a good mathematician, maybe in disguise. Like, they make a video, I'm a like guitarist, but I'm acting like a noob, and like that. Maybe he's pranking, like he's a like genius mathematician, and he's in my lecture and making a prank video that I'm like I'm sitting in a session, but I'm a genius because he can, like, focus a long, 29 minutes long session of maths till now. Then I really need to respect that. He's a great guy, and that too in this era, like, attention span problems. So he's a dope guy, I guess. So yeah, integration, and whoever is focusing, I don't know about others whoever are in this session, because in chats only I can see who exactly is there. So yeah, he is the one who is like stable, like he's continuously there. So yeah, like I can understand he is doing some, like, really good stuff, like in maths, I guess. So Laplace of integration of f of t. So what I can do here is, So I what I told you here is when it is division, I would take integration. When it is integration, I would take division. Simple stuff. So what I would do here, integration. Sorry, integration. So division by s raised to n. Also, I needed more space here because yeah, because always you won't have one integration in your question. There might be double integration, triple integration, and integration. So for n integration, you just have to keep dividing 1 by s raised to n to phi of s, like your result, whatever it is. And I had to put Laplace here, sorry. Yeah. Because without Laplace, this won't make sense, whatever I'm yapping. So I have completed your integration for shifting property. Now derivative have I covered? No, I have not covered derivative. Okay. Okay. So for derivative, wait a second. So it should be multiplication, right? Okay. So I have a remaining derivative. Sine I have covered. Divided by u is left. Okay. Divided by u, integration is needed. Okay. Okay. So now e raised to this I have covered, I guess. Second shifting property, yes, I have done. 4u cube, yeah, that I have done. Yeah, only this is also covered, I guess. I have covered this. Now what I only need is divided by t. Okay. Laplace of okay, f of t. No. Laplace of 1 by t raised to n f of t is equal to integration n times, okay, n times integration, like how like t square is there, two double integration, t cube is there, triple integration, like how I know, like you would yell at me that bro, we were skipping integration with this, now you are bringing up integration now sometimes, so you have to, at least it's better than taking Laplace of t raised to n, like we don't know even. So yeah, you have to take some integration. At least see, at least this job is a little easier right now, right? And no one in the world is giving you this huge question until you are doing research in it. Okay, maybe in research, I don't know. Maybe they are doing these questions, but yeah, I hope so. They are not even doing these questions, or else we are doomed. Okay, so you have to take integration of phi of s. Simple. Now what I have to do is I have only left is L of now I have done integrate derivative, yes, derivative by t dn by dt raised to n f of t. What it would be is, so what did I tell you? Derivative, then you have to go back to multiplication, go back to the roots where we came from, like we multiplied t, right? So now we are doing reverse. So what you do here is yeah, s raised to n phi of s, and this is kind of little complicated, so please try to remember it. So now what would happen is, okay, my ink is also dying right now, very good timing, thanks marker. My marker is dying right now, and things are gonna get complicated. Okay, now we are taking alternate signs. Okay, minus, we are taking s raised to n minus 1, like let's go previous, like whatever is there, we are just going back, f dash, like that much derivative you have to take, dash n minus 1, like if we are let me first let me do this, then I would give example because this is looking kind of complicated. Kevin Mori says better late than never. I'm really sorry, like I apologize, but I couldn't comprehend the question. Kindly enlighten me, like what, for what context you are saying, like I really apologize, I couldn't understand, like for what it was, like better late than never. So yeah, so tell me, like what were you saying? Like I couldn't focus because camera was like in lower side, like I have to put camera like here, so my it is like it is beyond my visual capability. So Yeah. So you have to take f of 0, okay, plus s raised to, so you have to just go on like this, okay, till you are just into s raised to 0, f n minus 2 0 till plus f of 0 dash raised to, sorry, f of 1 f dash, f dash, right, f dash here, f double dash here till n. So this is how it is. Oh, wait a second, was it not visible? Sorry. Okay, this is how it is. See, so what did I do here first for s raised to n minus 1? So minus 1 was. Kevin Mori says, "Oh, you were talking about integration. Like when? No, no, I was saying that you. So about you, what I was talking about? No, I was saying that about you only. That you can like focus on maths. Yeah, a session for like almost 36 minutes. Like this long session. So on online that too, and from a random dumb guy like me, so maybe you are a maths genius because in this era of attention span, scarcity, you have this much attention span. That's true for maths. From me, that too. So you might be a maybe maths genius who is just in a disguise, like pretending to be maths noob in a others like other session, and maybe you are making video that pretending like you have you seen those videos like I'm a pro guitarist but I'm pretending to be noob, then surprise others. Maybe I'm thinking that you are making a video right now, prank video, that I am genius but I'm uh like raiding noob math streamers, I guess, because I'm not a mathematician. I'm not qualified to say myself mathematician, maybe math streamer. So, noob math streamer, maybe you are making that video. So I was talking about you like in a appreciation mode, but in a trying to be funny. I know my funny joke doesn't land, but yeah, trying to be funny and trying to appreciate you. So it's kind of a mix. So yeah, like because you are stable, like you are till now, you are continuously on the session. So yeah, so I'm just saying that you deserve some serious respect, like respect from me, bro. So yeah, so this is all the yapping about Laplace theorem stuff. So yeah, I had to explain this. So let's say you have dq. Let's say I take triple derivative like d cube t d cube f of t by dt cube. So like I hope you are there, Kevin. So I hope you understood what I was saying, like the gist of what I was saying at that time. So equal to s raised to n, whatever is this, like raised to what? How many times? Kevin Mori says, "No, I am good at math, but I think you are a little better." No, bro, I'm a dumb guy, bro. I don't even know anything about anything in this mother nature in the world. I'm just trying step by step. I don't know anything about maths. I'm just trying, and maybe my mother nature is helping me. So thanks for your kind words. Thanks for appreciation. I don't even deserve that. Like I don't know anything about maths, but you are obviously better, bro. You are obviously better. You are any kid is even better than me in maths. So I think you are definitely 100% better, and you are humble too. That's a huge deal. Like you are humble to tell others better. So that you are definitely good at maths, or a good human, good as a human. So yeah, thanks for your kind appreciating the words. I'm not better. You are intelligent and emotionally intelligent, and uh, scientifically, obviously, you are intelligent. Maybe. Yeah. So what I was trying to say is like d raised to n, dt raised to n, when you do, like whatever power you raise, take derivative here, like how many times you take derivative here, power means how many times you take derivative here. Like dt raised to 1 means I take one time derivative, dt raised to 2 means dt square is I take two time derivative of this f of t. So let's say I take dt raised to 3, because that way I can explain you better in this equation, okay? Because I need three cases to explain you. So dt raised to n, dt raised to 3. Now I take, so how many times you took derivative here, that many times you have to convert it into s and multiply it. So s raised to n, so s raised to 3 you have to take, like s cube you have to take, multiply to the result. But now we can't operate with result because this is getting way too complicated, okay? Now what we are going to do is alternate minus plus sign. Now I would do is s raised to n minus 1. Now I would reduce this power and increase this derivative power. Like I'm going to take derivative here, but of f of 0. Now I'm not putting it in result, I'm just putting it in f of x. F of t is this. I am just putting now this 0 wherever there is t in my question. Okay, now I'm taking f of 0. F of s, phi of s is of result, whatever you find, like let's say this is your let's say dt here, okay? dt is here. So I solved these all and I'm here right now. Then I will put s in this result, but I would subtract it from original function, question function. I put 0. I subscribe to your channel, Kevin Mori says. For real, thanks for the support, bro. Really appreciate it. Deeply appreciate it, bro. Thank you very much for your kind support. Thank you very much. It really means a lot. Thank you very much. Really appreciate it. Really, thank you. I'm really grateful. Grateful for your kind support, bro. Thank you very much. So, so yeah, I did this. Now, I was reducing this power. S is power is reducing, and s raised to n minus 1, s raised to n minus 2. But this derivative power is increasing. F of 2, f raised to 2, then till and s raised to 0 would happen. Let me show you this. S raised to 0 would happen. And as you know, anything raised to 0 is 1. So that's why I was not writing this, because anything multiplied by 1, it is itself. So, but till here, it would be f raised to f raised to derivative till n, okay? So like I was talking about s cube, derivative cube, triple derivative. So here it would be triple derivative of question function, like question function. If I put 0 there, okay, in all the places there is t in question function, I would put t there. Take its triple derivative, okay? That's what it means. F of 0 means f of 0 here too, double derivative, like because it's increasing power, you know. Here single derivative of f of 0, question function, put 0, okay? That is f of 0. And I am taking single derivative, then double derivative, increasing derivative number, like number of derivative. And the multiplying s is reducing power. S raised to n minus 1, s raised to n minus 2, s raised to n minus still, s raised to 0. Kevin Mori C3955 says, do you do a lot of math on your channel at this time? Not at I don't have a fixed time. Like whenever I do, nowadays I'm doing, because I thought like formula would help a lot. Like I was uploading formula on my threads actually. So you have like many formulas, like one sheet notes. Like, do you know formula sheet? Like in one sheet we try to fit all the formulas. I thought that would help a lot. Like I did that formula sheet, I was preparing and uploading, and I have done of almost every, like most of the chapters. So I have done it, modules, for most of the modules I have done it. But the problem is application is still difficult, and it never crossed my mind. And I didn't actually, I hesitated to do it for some time, because firstly live stream was a new feature. I don't know, I didn't knew how to handle it. Also the second thing was like I was not, these IRL streams I was not like adapted to. And third thing is I thought that solving this would take a lot of time, so I hesitated. So but now I'm trying to do it one by one, so I feel like it is okay, like it is not taking infinite amount of time maybe, but I don't know, because still I have not covered everything. So, but yeah, but I used to do formula sheets mostly earlier. I used to write all the formula and just upload it. So, yeah. Do you do a lot of math on your channel at this time? Not a lot, but yeah, a little math I do on my channel at this time. Yeah, time not fixed. Time is not fixed. Okay, I hope you got the answer, Kevin. So, were you disconnected, Kevin? Were you there? I hope you were there. So, I hope you got the answer. So yeah, what I was saying is s raised to n. So that would reduce, like power of s would reduce, and phi of s will only come one time. Okay, and if they were doing like derivative, like here it is derivative raised to zero. Why there is no derivative here? Because obviously, since it is increasing from zero, like first derivative is here, so this is zero derivative. Okay, zero derivative. So zero derivative is no derivative raised to zero, like one, right? So no derivative. So what the thing is now? So what I'm trying to say is like, since we are doing f of t derivative, and to simplify that, obviously we would not do derivative of result, right? That would make things way beyond complicated. That would be much more complicated. So what we're doing here is we are taking derivative of like f. Okay, we are taking derivative of question, so we are trying to simplify it here. We have to take derivative, that is inevitable. So we are taking of question function, not the answer function. Kevin Mori says, yes, I'm here. Glad to see that you are here, because my the stream like parameters say that that there is no one in the session currently. So yeah, it might be glitching. It glitches sometime. I'm just glad that my chat works. Like sometimes chat even doesn't work. Like there are, I can see the chats later, but during stream I don't. I am not able to see like chats. I guess it is working now properly, so I'm glad enough for that only. And also I'm really glad that you are still here. Thank you very much. So yeah, so I hope you understood that we won't take a phi of s derivative, because that would only make things complex. But we can take derivative of the function if we put zero in it, right? And that's simple, right? If you zero, most of the time it is either gonna come one, like raised to zero something, it is gonna come one, or if it is multiplied into zero, adding zero. If we add zero, same thing's gonna come. If we multiply by zero, obviously zero is gonna come. So most of the times this doesn't even bother us mostly. Okay, so I have listed down the formulas right now. So I would like to zoom out so that you can take screenshot and notes. Okay. Also, I have to like write the shortcuts here too. Take constant out, and separate Laplace L of f of t, and I guess there is no more shortcuts, I guess. And this is actually, I'm telling that what is phi of s. Okay, this is not any formula. Okay, so yeah, this is how it works. So this is whole lot of Laplace things, like whatever you require. So I have to check it again, but okay, focus or not there, I guess. Focus camera. What is happening to my camera? Yeah, I guess it is in focus right now. I hope you have taken screenshot or notes. Now what I'm gonna do is, so I'm gonna re-verify it, okay, from my notes if I have given it everything correct, because I don't want that at the end of the day you have wrong formulas and you end up in trouble during your stuff. And then it would be then it would be rather pointless of my doing stuff if it puts you in trouble. Rather, it would be worse if I tell you wrong things. So I have to do correction. I was trying to just recall from my back of my mind. I was trying to recall all these formulas. Now I'm gonna re-verify from the notes. Okay. So yeah, first is definition. So yeah, we are here. Integration 0 to infinity e raised to minus st f of t dt. Correct, correct. We are correct here. Okay, no issues with that. L of okay, linearity property. L of k of f1 of t plus f of 2 k to f of 2t, correct, is k taken out, L of f1 of t plus k to f1 f of t. Yes, this is correct. Just we just have to separately take L of f of t. Okay, that's how it is. Oh, now also we have to see elementary functions like basic functions, whatever Laplace is. So e raised to at is I just have to check one because other is just changing the sign. Like if, so, you have to remember this. I forgot this shortcut. That see this is minus here. Just take opposite sign. Opposite sign. Okay. This is minus 80 becomes plus. Plus 80 becomes minus. Simple. And obviously this is itself short like L of k by s. Simple. Just divide by s. Simple. Like in Laplace, you are just gonna see s, and s is actually here like whatever e raised to whatever was there in the beginning. Okay, like see, this is a huge function, but since it is in a pattern like 0 to infinity e raised to minus 2t, so that's why we can solve it without integration. So that's what skipping integration means, because most of the area we are just adding s plus a, s plus a, s minus a. We are most of the area we are not doing integration. Only one place we are doing integration and derivation. I don't know why we're doing that, but yeah, but most of the places we are not doing. So that's what skipping integration means. That's what cheat code shortcut means. Yay! Bingo! So yeah, L of k is k by s, correct. L of e raised to at is s by s 1 by s minus a, correct. So this is gonna be opposite of that, correct. L of cos at is s by s square plus a square. L of cos at is equal to s by s square plus a square. Yeah, I told you. No s at start, so s would come here. No s at start. Okay. In hyperbolic, what would happen? Plus becomes minus. Opposite sign. Okay. And I explained that during the live, like why it is minus. Okay. Like it is not exactly that, but because like I'm just giving you a memorizing technique. Okay. My hands are a little shaky right now, so that's why maybe camera must be blur. So sorry for that. I'm changing hands, but yeah, it is still a little shaky. Humidity and heat is kinda on the top of the charts right now. Hashtag summer season, hashtag super El Nino. What can we do? And I don't know if El Nino is in full extent or not, or is there more to endure? So L of cos at is s by s square plus a square. Done, correct. Told ya. Like cos c is not there at start, so we put opposite. We are just teasing that function that bro you don't have s. We are doing s by s square plus a square. Only e has a linear denominator, like denominator s plus a is there, but others have s square plus a square denominator. Like you just have to do same thing but square. You have to take like quadratic form. You have to take. Now L of sine at is a since c I told you like there is s at start, so we take opposite a. Like there are only two variables s and a, so we are taking opposite of s because s is at start. So I take a by square plus a square sine h of at, a by square minus a square cos of h of at, s by square plus a square. Oh, sorry, I had to check. Sorry, what I am reading. So L of cos h at is equal to s by square minus a square. Wait a second, what? Okay, yeah. Oh, wait a second. Oh, yeah. L of cos h of at is equal to s by s square minus a square. Yes. Let's go. So it is correct. It is correct. L of t raised to n, right? L of t raised to n is equal to n factorial by s raised to n plus 1. Yes, correct. Let's go. Let's go. We can do this. Now, what's the change of scalar property?